Having worked with logarithmic functions now, we can discuss the graphs of logarithmic functions. So, as in exponential functions, the value of the base matters. If a is bigger than 1, we have an increasing function, just like with exponential functions. In fact, the key points are exactly backwards from what we saw with regard to exponential functions. And the reason for that is because these are inverses, so x's and y's get swapped. Our vertical asymptote is x equals 0, and it can shift based upon transformations that may occur. The domain is going to be x is positive for our parent function, and the range is all real numbers. If a is between 0 and 1, our function is decreasing. Everything remains the same as before, except the location of the points in relation to one another is changing. The same key points still exist. Now, if we are going to try to find the domain of a logarithmic function, we can take the argument of the logarithm and set it greater than 0 and solve that inequality. To find the vertical asymptote, we can take the argument of the logarithm and we can set it equal to 0 and solve that equation. So, let's go ahead and find the domain, the range, and the asymptotes of this function. So f of x equals the natural log of x plus 6. So, if we had y equals natural log of x, we would see the key points. -1, 0, 1, 1 over e, which is the base, 1, and e. Now, this function, natural log of the quantity x plus 6, would be a shift of everything to the left 6 units. Now, let's just quickly check the domain of our function. The domain of our function, we would take our argument x plus 6 and set it greater than 0. So x would be bigger than -6. So the domain would be -6 to infinity. The vertical asymptote would be if we take x plus 6 equal to 0, so x would equal -6. So x equals -6. And we will find our function to be to the right of that because x has to be bigger than -6. Our key points, 1 over e, comma -1, 1, 0, and e, comma 1, yield this function, but we're shifting that all to the left 6 units. So, instead of 1, 0, we're going to have -5, 0. And then I think it's easiest to move e, comma 1, and then 1 over e would get shifted to the left also, 6 units. So there's f. Let's go ahead and find f inverse, its domain and its range. Actually, we haven't found the range of our function, but it's easy because the range of our logarithm is always going to be all reals, -infinity to infinity, which we can see on the graph. So f inverse, we will go ahead and take and replace y or f of x with y. And so we have y equals natural log of x plus 6. This is our original, but now we'll switch x and y. So we have x equals natural log of y plus 6. Now we'll convert this to an exponential. The base of our logarithm is e, so that will be the base of our exponential. In our logarithm, the base and the exponent have been separated, so our exponent will be x. So e to the x equals y plus 6. So then to solve for that, we get y equals e to the x, then subtract 6. The domain of this is all reals, and the range is going to be -6 to infinity. How do I know that so quickly without doing really any more math? The domain and the range will switch for our inverse. So the domain of f is the range of f inverse. The range of f is the domain of f inverse. And now because we've switched x and y, what was a vertical asymptote is now a horizontal asymptote, and we switched x and y, so it'll be y equals -6. So to graph this, I'll graph it in green. Y equals -6. And what we can do is switch the ordered pairs. So instead of -5, 0, we would have 0, -5. And instead of this point, we could switch the ordered pair. So it'd just be -1, comma, a number just above -6. And then likewise, we would have 1, comma, and then that would be -4, or a little bit above -4. And our function would be increasing. So this is f inverse. And of course, as always, if we graph the line y equals x, you can see the mirror that would take place between f and f inverse. So in this problem, we will do something very similar. We will look first at the parent function, y equals log base 6 of x. So our x and y is there. Would be -1, 0, and 1 for y. And then we would have 1/6, 1, and 6. These are just from the guide points. And then what we're going to do is f of x is, if I rewrite it as -log base 6 of 2x, then add 1, then I have 3 transformations. We have a horizontal shrink, there's a reflection about the x-axis, and then there's a vertical translation up 1. Now, none of those move the vertical asymptote. If we set 2x equal to 0, we get x equal to 0. The domain, we set 2x to be bigger than 0, and we would get x is bigger than 0. So our domain is 0 to infinity. The range is going to be -infinity to infinity. So now, if we have our vertical asymptote sketched, if we take 1/6, -1, and we shrink it horizontally, That'd be 1/6, comma, -1. We would shrink it so it would get closer to the x-axis. And then we would reflect it about the x-axis, so it would be up here. And then we would move it up 1, so it would be a +2. So we have a number 1/12, comma 2. Then if we check 1, 0, shrink it by a factor of 2. So we're at 1/2. Reflection does nothing to this point, and then move it up 1. We'll have the point 1/2, comma 1. And then 6, comma 1. We would shrink it, so that'd be 3, comma 1. Reflected about the x, so 3, comma -1, and then move it up 1, so we would have 3, comma 0. And so our function in this case is decreasing, but that's because of the reflection. Now, let's find the inverse. So to find the inverse, we have y equals 1 minus log base 6 of 2x. I'm going to put that 2x in parentheses for emphasis. We will swap x and y. So we get x equals 1 minus log base 6 of 2y. Subtract 1 from both sides. Now we can divide everything by -1, which changes the signs. So we have -x plus 1 equals log base 6 of 2y. Now convert this to an exponential. So the base will be 6, the exponent will be -x plus 1, this equals 2y. Now, if we divide both sides by 2, we have 1/2 times 6 raised to the -x plus 1 equals y. Now we cannot take 1/2 times 6 because the exponent has to take place first. So this is our inverse. F inverse of x equals 1/2 times 6 raised to the -x plus 1, and its domain and range can be found by looking at the domain and the range of our function and switching them. So the domain of f inverse will be -infinity to infinity, and the range will be 0 to infinity. Now, how do we graph it? We have to convert the vertical asymptote to a horizontal asymptote. So I'll do that in green. And then all of our points switch. So instead of 3, 0, we will have 0, 3. Instead of this point, 1/2, comma 1, we will have 1, comma 1/2. And then instead of this point, we will flip it, and so we will have 2, and a little bit higher than that. So now, what's that look like? And again, if you were to draw the line y equals x, you would see the reflection.